and welcome. My name is Artem Sentsov. I'm founder and CTO at ClearPic, and ClearPic is a screening platform focused on high-risk commodities markets in Central Asia and the Caspian region. And our platform helps automate counterparty due diligence and know your customer procedures. And today I want to tell you about how a knowledge graph helps to find hidden connections in data. For example, how long does it take a compliance team to check one company in Central Asia? I'll tell you what our clients told us before they came to us. It's 1 or 2 days. We get it done in 2 minutes, and let me show you how. But first, let me tell you about the data. Central Asia. So each country has its own business registry. Sometimes not 1, 2, or 3, because different government agencies run their own registries. No direct access, no standardization, no proper search, and the data itself is also quite messy. For example, the same person in one registry is Halimov, and another is Halimov G, and in a third it's spelled in Latin, not in Cyrillic. So what we have here, it's like the same person, 3 different spellings, and 0 connection in a government database. And it gets worse. For example, 5 years ago, it's spelled one way. 2 years later, without the patronymic name. Right now, with it. So that breaks any system which will try to connect all the dots from different datasets. And basically, that's enough to disappear from a standard compliance check. And that's why, let me show why standard tools failed here. You can ask me, why can we just use a relational database for this use case? Try to find all entities connected through 3 intermediaries across millions of records with different name variations and address inconsistencies. Your query explodes. Your join becomes a nightmare. Okay, you can say, what about LLMs? Right. LLMs are great. They're flexible, powerful, but there is only one problem. They hallucinate. They will confidently tell you 2 companies are connected with no evidence. And they will tell you the opposite, also quite confidently, also without evidence. And there is a deeper problem. RAG cannot guarantee transitive closure. For example, if A connects to B and B connects to C, RAG will not reliably find that A connects to C across a number of records. And for compliance or for investigations or even for basic KYC checks, that's not a feature, that's a liability. And we needed something that thinks in relationships, not rows. And here is what we built. 5 stages. First, we ingest data from hundreds of data sources. It's different data sources. Second, we run NLP and entity resolution. For example, fuzzy matching, duplication, name entity extraction, you name it. Third, everything goes into our knowledge graph in Neo4j. Fourth, we do analysis, graph algorithms, custom risk scoring, for example, link prediction or centrality detection. It's really helpful. And fifth, it's actionable insights about companies, about businesses that are delivered to compliance teams through our web platform. And what can I say here? NLP gives us flexibility. And graph gives us speed and consistency. And that combination is what makes it work at scale. And let's have a quick look what is a knowledge graph. I believe everyone here knows about knowledge graphs. But let me make sure that we on the same page. So a knowledge graph has two things. It's basically nodes, the entities, and for example, person, company, address, court case, contract, etc. And relationships. So it's connection between those entities. They can be typed, directed with properties. So for example, in our use case, a person who owns a company, it has a share, 51%. So that's it. And a bit of theory behind of the concept of knowledge graph. So knowledge graph it basically contains two items, two entities too. So it's ontology, like the conceptual blueprint, the rules, and the taxonomy. It can be called a linguistic model, for example, handling terms, synonyms, transliteration, like also a set of rules that describe our data. And the data graph itself, the actual instance data. So for us, it's useful because a database, it stores facts. And the knowledge graph, it stores meaning. And why it helps us? Because it resolves ambiguity across sources, different sources, because we have sources in different languages from different government agencies, and we need to resolve this ambiguity. And also knowledge graph breaks down silos between structured data, documents, media. You can continue this list. And also knowledge graph grounds LLMs in verified facts, like it excludes any hallucinations. So for us, the graph is a ground truth. And that's the structure. Now let me show what we put into it. So where does our data come from? Earlier, I said that we have different sources, but right now I can call it different layers. So first layer is public registries. For example, corporate records, ownership structures, like list of directors, shareholders, procurement records, sanctions list, local watch lists from all jurisdictions that we cover. Second layer is court records. We have like a lot of records on court cases. It's unstructured data that basically is published in PDF in the local languages. So it's unstructured text in Uzbek, Tajik, Mongolian, Azerbaijani languages. Pretty hard to digest, pretty hard to analyze. And that's why we run an NLP pipeline. So we extract parties, case types, amounts, outcomes, dates, and then we transform unstructured legal text into structured graph data. Why does it matter? If a director has been a defendant in 40 cases across 3 countries, that's a signal. A registry will never show you that, and a core database will, but it's different sources. They host different type of data, they provide it in a different way, and we need it to be unified. And the third layer, it's media and open sources. So news articles, press releases, investigative journalism. We extract named entities, people, companies, events, addresses, contacts, and we link them to what's already in the graph. So when you query a company, you don't just see who owns it. You see who sued it, who wrote about it, who and what they said. And it saves our clients time, big time, big time. They don't need to Google a company or a person in an unfamiliar language, local language. It's already in our system. So every new data source adds a new type of edge. The more edges, the harder to hide. So we have 3 layers of data. Now, how do we connect them? And there is the hard part. How do you know that that person, Halimov in Kazakhstan, is the same person as the Halimov G in Uzbekistan? Exact match says no, it's different, different entities. Our system says probably yes, and here is the confidence score. We use 3 techniques for it. It's phonetic matching, soundex, and metaphone. We adapted it for Cyrillic and local Latin scripts, for example, like in Azerbaijan or in Uzbekistan, because in Uzbekistan they have 3 scripts, Cyrillic and Latin, and they use them both. And this phonetic matching, it handles transliteration variations. Also, we use contextual embeddings from fast text and BERT, same address context, same registration periods, for example, some similar surname, different spellings of company names, etc. So the more these embeddings, the higher confidence. And the third one is probabilistic scoring. It's a number between 0 and 1. So, for example, if we have a name similarity and address overlap and some registration data alignment, it means higher score. And the real challenge here is not the algorithm itself. It's the data that is bad by design, because one change in a name, dropped patronymic name in a full name, it's basically enough to break exact match. But it's not enough to fool probabilistic scoring, because it's really powerful. So the graph is built, and it should has been to describe like that, like nodes, edges, query capabilities, etc. And that's a real screenshot from our system. So each node is verified, duplicated real-world entity. And each edge is a typed relationship with a confidence weight and a timestamp. For example, a person owns a company, the company is registered an address, and that address connects to another company. And you can click through the graph and understand all the connections. And this is what a QIC check looks like when you stop searching rows and start traversing a knowledge graph. So we can, for example, enlarge it and see, like, there is a pretty lot connection, for example, from one person to other companies and addresses, and it's really, really helpful. Okay, so that's the structure. And now, what does it actually find? Here is like a quick description what our graph allows us and our customers to find in this messy data. And that's like a real scheme from Neo4j. And this scheme I really love showing customers. And this one is circular ownership. So a company owns a shell, which owns another shell, and which owns the original company. So the company owns itself through a layer of intermediaries across two countries. And that's the pattern that can hide billions in assets. And the SQL query will never find that from, for example, one source or even with different sources, because it will be like a lot of joins. But our graph finds it automatically. And we also can find ultimate beneficiary ownership chains, like the real person behind layers of shells. So this person, and he owns the company. What we can also use, for example, it's shared identifiers, shared entities too. For example, 10 unrelated companies, they share in one address. It can mean that it's a coordinated structure. So it's flagged instantly in our system. And when we cross-reference with court records, for example, a director of this company can be appearing in court cases across the region. And what took investigators weeks, our graph does in under a minute. So finding connections is one thing, but explaining them is another. Because that's the problem we kept running into. Compliance teams, they don't trust black box scores. You cannot say the company has a risk score 0.79. They will ask why. Show me the evidence. Show me how you got that number. So that's why we are building GraphReg. And here is how it works. So user asks, summarize compliance risk for company X, right? And Graph finds all verified connections, ownership chains, court history, media mentions, procurement records, watch lists, and LLM receives the structured verified context, not the raw internet, not its training data that can be potentially corrupted or poisoned, like deliberately. It's the graph. It's like our verified connection that is connected to real sources that we can trace. And the LLM never invents, never hallucinates some connection. It can only explain what the graph has already verified. And for investigators, for compliance team, for regulators, that auditability is everything. So vector search finds what is similar, and GraphReg finds what is connected. And the difference between a search engine, and basically that's the difference between a search engine and an intelligence platform. And the intelligence platform has its own engineering reality. And let me be honest about how this works in production. So our full graph is around 500 gigabytes in memory. We can do a three-hop traversal queries like in sub-seconds. We can extract it pretty easily, but it also has some trade-offs. So, for example, the classic trade-off about recall and precision. So we lowered our confidence threshold to 0.85, and we accept false positives in this case. Why? Because real-time updates break transitive closures because it's noise. But for us, consistency over freshness for compliance, for example, that's the right call. And also, one of the hardest part for us is encoding normalization because we handle 7 languages, and one language can use Cyrillic and Latin simultaneously. Also, some old Soviet style spellings versus modern native spellings. As I told, Halimov or Halimov-Jan, etc. For the computer, it's like different names, different persons. But in reality, it's the same person, but different surnames across time. And also, we used our own training data because we labeled 500 clusters, like exclusively by us. Even more, maybe 1,000. Yeah, it was a lot of work to do. And engineers who say that they have 0 false positive in their systems are lying, basically, because honest trade-offs are what make a system trustworthy. And so what we did produce. So we have more than 25 million data points from corporate records, and they're unified in one graph. And we get a 40% increase in hidden risk detection versus traditional methods of investigations. And we have a pretty dramatically reduction in investigation time that saves a lot of time for our clients. And also we automatically identify more than 15 financial crime patterns. So what I can say, so checks before it was days, right now it's minutes. And a single graph query gives you court history, litigation records, procurement involvement, watch list status, full ownership clusters, etc. And everything, one query in a few seconds. Yeah, but those are the numbers. As results, they're great. But here's what we learned building them. So here's what we learned. It's hybrid always beats pure. So NLP plus graph beats pure LLM and pure SQL. Because we are working in a noisy, multilingual environment. So we should invent something. Also, probabilistic is more important than binary. In highest noise data, confidence scores are more powerful than yes or no. And explainability is not optional because compliance teams, they need to see the path through the data, not just the score. And the knowledge graphs deliver explainability natively because like that's not a feature, basically, that's a product. And basically, courts and media, they are underused signals because they will tell you what actually happened. They will add more context to corporate registries because corporate registries sometimes can be impartial, they can be corrupted, etc. So our graph is never finished. We always working on it. We add an incremental updates, trying to add real-time updates. We also trying to build auto detection of adversarial obfuscation, because some bad actors deliberately poison records to evade detection. And we expanded to new jurisdictions and data types. And if you are working on entity resolution at scale, graph architecture for compliance, or for financial intelligence, I'd love to talk. Thank you.